Hello everyone, this is Ms. Howington from Research Triangle High School. Today we are going to talk about gravity. So first of all, what is gravity? So gravity is the force that attracts anything in the universe to anything else in the universe. But they do have to have mass. So it's a force that attracts any body towards another body with mass. So I like to think of it as kind of like an invisible stick that holds two objects together in outer space. It also works here on Earth. It's the force that attracts us to the Earth as well. So gravity, there's two relationships. We'll investigate this one a little bit more. So gravity gets stronger as the objects get larger and weaker as they get smaller in mass. And then gravity also is stronger when objects are closer together and weaker when they're farther apart. Okay. The center of gravity is the point in an object or a system from which it is considered to act. If that's not confusing, I don't know what is. So in other words, it's the point where something would balance on your finger if it was one solid object. So we have a ruler. So if I can find the point that it balances on my finger, I don't think I'm going to find it in this video, but that would be our center of gravity. There we go. Center of gravity of the ruler, the point where it balances on my finger. So it's a lot easier for things that are one solid object, like a ruler. And then we have a hammer. So the point where it would balance on your finger, I might break a toe with this demo. All right, so point where the hammer would balance on my finger is somewhere in there. So notice where the barycenter is in an object that has uneven mass, or so the center of gravity, where that is in an object that has uneven mass. So the head of this hammer is way heavier than the rest of it. So keep that in mind. All right. So now for how this applies to outer space. So we need some other vocabulary real quickly. So binary bodies are two objects in space, also known as celestial objects, that are held together by mutual gravitational attraction. There we go. So for example, there's our sun and the Earth. They're binary bodies because the gravity between them is keeping them held together. Other examples could be any of the other planets than our sun and other stars, the Earth and the Moon, lots of things. So a barycenter is a center of mass where two or more celestial bodies orbit each other. So if we look at an example of like the sun and the Earth, where the sun is way more massive than the Earth, that barycenter is going to be, this is too long, it's not going to work. So that point where it's going to balance and be perfectly even is going to be way closer to the sun. And in fact, it's inside the sun. And it causes the sun to weeble wobble like a tiny eensy weensy amount that we can barely detect, and so we usually kind of ignore it. So another example could be the EarthMoon barycenter. So if the objects are a little bit closer in mass to each other, it's a little bit farther out in the sun, or in the Earth. And so when the Earth and the Moon orbit, they're kind of like wobbling. So they're orbiting a point that's kind of over here, which causes the Earth to wobble a little bit. So hopefully you get the idea of barycenters. We are going to play with some Play-Doh and some imaginary lines of gravity in class to kind of get this concept more stuck in our heads. All right, guys, see you in class.